Hey everybody, I just wanted to do a quick technical deep dive into our ETH DAO's DAO governance platform that we're building. It's coming out through Astroflora, and this is our dashboard that you'll see that lets you connect to any ETH DAO ICRC 149 canister and administer your Ethereum DAO that is scaled via the internet computer. And so basically, the idea is that you can connect to any network, any EVM network. Here we have a local network, and you can connect through your various addresses to you get assigned a treasury address, which is your address that can hold assets that is owned by your DAO. And it's a non-custodial address. It uses threshold ECDSA to make sure that there's no private key out there that someone can go grab and run off with. You don't have to organize 3 or 4 people to go multi-sig and execute something. It just happens when a proposal passes. It will be executed. We can go and we can create, really, right now there's 3 different types of proposals. There's your standard motion proposal where you can say, temperature check or something like that. Do a poll. There are Ethereum transactions where you can send around ERC20 tokens to a new account, or you can just submit a standard. If you have a transaction builder, you can go and construct your transaction and submit it here. And then we have ICP canister calls. So if you want to hold assets or exchange assets on an IC computer canister, you're able to put in the canister ID and either manually enter in the transaction, or this should get you a form to construct your ICP transaction. So if we want to, this is our actual our Ethereum DAO canister itself. So I'm just going to put this in here. When I click the load interface, it will then give me all the methods. You can see all these ICRC49 methods. This is sort of a great place to look and technically see sort of what we have available. Lots of different functions here to get your proposals and set controllers and all kinds of things. So let's say we want to, so here this would let us change the EVM RPC canister that we wanted to talk to. And so we would create this proposal, and then once we do that, we will go vote. Let me show you a quick test proposal here. We'll just do a quick one. Create the proposal. It makes sure that this is providing a proof that we actually own some tokens on that chain. And then once we're here, we see that there's only an hour remaining. Here's our proposal, and you can vote to adopt it. When you vote to adopt it, you're providing proof that you owned the proper number of tokens at that particular block. So we confirm that, and then after we vote and refresh, we should see that we have now 100 votes, because that's how many tokens we had. Technical deep dive. How do we have this project set up? Well, we do a lot of testing. So the best place to really see how it works is in our pick tests, and you can go in here and sort of check out the end-to-end governance pick test, and you'll be able to see that all the things that we sort of have to set up. So we do our sign in with Ethereum proofs. We have libraries for that. We have to spin up an Anvil process, which is a local Ethereum process that mints a smart contract. So that's all integrated so that you can test. It kills it and shuts it down after each test. You can see that it sets up these sign in with Ethereum messages correctly, and then just runs a bunch of tests. It'll walk through creating the proposal, allocating the tokens for people to vote, then creating the proposal, then letting everybody vote, both positive and negative, different scenarios, and then executing. It sets up a transaction to send some tokens to another address, and then it will confirm that actually happens on your local RPC canister. So that's really a great place to dive in, to look at some of these tests and to see what's actually happening behind the scenes. And then, of course, we have our backend library. This is written as a Class Plus style library. So if you want to build your own thing that interacts with EVM RPC canisters and does this, you can just include this. Eventually, you'll just be able to include this library for mops and start to build your own, implement the functions you want, secure it the way that you want, and we do that for ourselves here in main.mo. So main.mo has all of the wrapped calls into the library. So you can actually add this library to like a ledger canister and give your ledger cool Ethereum superpowers somehow. A lot of these functions, since they do things, we'll be adding sort of an SNS superpower where, obviously the SNS already has proposals and custom function calls, so you'll be able to deploy one of these canisters, give the SNS sort of administrative rights, and it will be able to do all the things that Ethereum DAOs can do as well, except governed here on the internet computer. So that means owning assets on all the different base chains, or all the different EVM chains like Base, Arbitrum, Binance, all of those, as well as being able to call any contract on those chains. Now you do have to fund your per chain. You have to fund your treasury with enough native ETH to pay for the transactions, and we'll build a nice interface for that. Speaking of interfaces, we have the front end where Ethan's been really busy this last few weeks, replacing our front end with this nice svelte based front end. So when you look at this here, this is all Ethan's work. There are settings here where you can go in and add. You need to authorize the token governance contracts that each ETH DAO backend canister will listen to. So a number of DAOs can theoretically share one, but because you have to own that native ETH, it's probably best to have your own. But perhaps you have different kinds of contracts that you want. You may have a staking contract on Ethereum where your core token you maybe use for proposals so everybody can vote, but then your assets are owned by a staked contract. So if you want to be able to own that, you need to send your tokens into a staked contract and lock them there, and that would work as well. Switch back and forth between your local development and the dev feature, and that's sort of where to get started on the technical deep dive. Maybe looking at our DFX file might reveal a little bit. You can see that we have our backend canister. We pull the EVM RPC canister with depths, and we have front end canister. It's pretty straightforward. That is really it. And thanks for the opportunity to show you what's going on behind the scenes with our canisters.